second example is a good example for us to practice our algebra, but is a very bad real-life word problem. Because look at it. Clara and three friends were born on March 11th. Yeah, how likely is that? Then, somehow you know that Leslie is 5 years younger than Clara, Mike is 2 years younger than Clara, Thomas is 3 years older than Clara, and instead of knowing how old Clara is, you magically know that the product of their ages is 61,136 greater than their sum of their ages. This is like common knowledge out there. But you have no idea how old Clara is, right? If this was a real life problem, ask Clara, how old are you? That is the best solution. We don't need any math whatsoever, right? If she doesn't know, then, stalk her on social media. You'll find out somehow, right? You can probably figure it out. But as a math question, it's designed just for us to practice our math. So how do we go about practicing our math? For that reason, it's okay. But as a real life word problem, this is ridiculous. Like as if this would come up. However, the previous question of actually taking the amount of material and wanting to make the maximum size box possible, this is something that all sorts of manufacturing businesses use all the time to try to make the biggest profit that they can make. They're always thinking about how can I maximize things, minimize materials, what's the best way to do something. And companies that figure that out, like what company ships things in the smallest packaging possible and then you have to build it at home and they make tons and tons of money? IKEA, right? They figured that out, right? While other companies were using huge container boxes to ship completely built couches and completely built wardrobes, they were shipping them in smaller containers. And they were saving on money because they're like, oh, and you get to build it, right? So they save on labor that way too. So now they're maximizing their profits, and they're a big company making tons of money, whereas other furniture companies go out of business. So these things are important. But the ages one is just for practicing. So what we're going to have to do is we're going to have to say, let's make Clara's age X. How old is Leslie then? 5 years younger, would that be X minus 5? Mike is 2 years younger, so we'll make Mike X minus 2. And Thomas, X plus 3. Right, and Clara doesn't tell you how old she is? Ask Thomas. Thomas, how old are you? How old are you? 16. Perfect. Then we can figure out that since Thomas said he was 16, Clara must be 13. We're good. We didn't even have to stalk her on social media or anything like that. So life is good. Now, what we need to do is make an equation, and we've got this crazy thing here. The product of their ages, they're comparing the product and the sum. So I'm going to make an equation. I'm going to put product on one side in words, because I'm just thinking right now. I'm going to put the sum on the other side. Obviously, they're not equal. One of them is bigger. On one of these sides, I would have to add 61,136 to make them equal. Which one's bigger, the product or the sum? The product's bigger, so does it make sense that I would have to add the 61,136 to that side to make them equal? And now that we have the idea in words, we can put the idea into algebra. What does product mean? Product means you multiply them together. So I'll switch to blue here. I would have x times x minus 5 times x minus 2 times x plus 3 equals. And this is why it's nice to write it out in words, because sometimes when we get working with the algebra, algebra has a great ability to make your mind forget what it's doing and get lost. I don't know, it's not its job, but it does that. So having it written out, I'm like, okay, I just wrote the product. What do I need to write on the other side? The sum. If I add those all up, you see that that would be 4x and then negative 7 plus 3, 4x minus 4, and then I still have the 61,136 on that. And the technique with our graphing calculator that we're going to do with equations where there's something on one side and something on the other is we are going to type one side into y1 and the other side into y2. And we still need to have some sort of sense of what's going on algebraically and graphically for these in order to draw this properly. So first of all, I'm going to type them in. So I'm going to go to y equals, I'm going to clear out what I had, and on equation 1 I'm going to take x times x. That's the first one. X minus 5, x minus 2, x plus 3. X minus 5, x minus 2, and x plus 3. I type one side into y1, push enter, and the other side, 4x, I'm going to combine my like terms, plus 61132. I added the minus 4 and the 61,136 together and got 61,132. Now if I'm on a normal window, so if I hit zoom and I go to 6, this is a normal window. I see the blue graph. I don't see the line whatsoever. Mine is color-coded, so if I look, my line should be in red. It makes sense that I see some of my blue graph because there's my x-intercepts and they all have a multiplicity of 1. This would be an x to the 4 graph. So that makes sense. If I zoom, if I hit the zoom button and hit zoom out, it shows me more of the x to the 4 graph. I still don't see the red graph at all. This is where we need to understand graphically how to graph things without our calculator first. Because if you just keep guessing and checking on your calculator, it's going to be problematic. Right? And most likely it's going to start looking like this. Look at the red graph. 4x plus 61,132. We need to recognize that is a line. Y equals mx plus b. The y-intercept is at 61,132, and the slope is positive. So when I go to my window, my y max has to see that 61,000, and it has a positive slope, so it's going up. I'm going to go up to 70,000. For my x's, I'm going to have -1 just so I can see my x-axis, but I'm pretty sure that Clara is not -7 years old. That would be problematic. Okay? So for my x max, I'm also not going to put 1,000 in here. Based on the question, it'd be like, we got Clara is 382 years old. Like, this is a really bad word problem then. So maybe I'll go up to 100 because I'm pretty sure they wouldn't all be that close to 100 years old. And I hit graph, and now I see my two lines, and they intersect nicely. Our calculator can find out where they intersect by going second, calculate, number 5, intersect, push enter. It'll automatically be on one of your curves, and it says, which one do you want as your second curve? You push enter on your first curve, on your second curve, and then you guess, and x is equal to 17. So that means Clara is 17, Leslie is 12, Mike is 15, and Thomas is 20. And that's the solution for a question that's just getting you to practice taking information and being able to put it into an equation, but it's not a really good real life problem because this won't come up. But being able to solve things does come up in real life, so it's still a good skill to have and a good question that way. You can circle questions. Did I get you to circle questions 7 and 8 on the last one? Yeah. Okay. 7 and 8 were the ones for this one. For the ones for the last one are 3, 4, 5, and 6, 9, and 10. So basically, it's all the questions from 3 to 10 in this section. Next, I'm going to get you to turn to page 56, and we're going to do one more example, because on your provincial exam, graphing calculators are not allowed, so obviously they're not going to ask a question that figures out these maximums and minimums with a graphing calculator. But they can still ask a similar question without a calculator. So here's an example of an exam question that came up on the non-calculator part of the exam. You have an empty page on page 56, so I'll give you some time to write it down, and then we'll look at solving this. We might get it done by the end of class. We might have to finish it up tomorrow. And I'll put one similar to this on your test. All right, so a box in the shape of a rectangular prism. So again, we draw a visual of this straight up, straight across. There's our box. Has side lengths of x, x plus 2, and x plus 10. Write the volume, write a function volume. Here's my function. It's going to be length times width times height, whichever, doesn't matter the order. My height, I guess, was x. So on this question, when it was on the exam hall, this question had controversy. It was worth 5 marks. And there was controversy because there was a number of students who got the right answer and got 2 out of 5 marks, which made students angry and their teachers angry. So we'll talk about what are some of the things that came out of this question. Okay? Now, controversy came in part B. It said, find all possible values of x given that the volume of the box is 96. So you would know that the volume is 96. And at this point, the marking guide gave people, I think the students that got the right answer got 3 out of 5, not 2 out of 5. At this point, you got 2 out of 5 for both of those. 1 for writing the volume equation, and 2, you got a second point for putting in the 96. Now, since it was non-calculator, students were like, the answer has to be pretty nice. Wouldn't you agree? It's not going to be 1.738? Most likely not. So, do some guessing. Tell me what the answer is. See if you can do some mental math. Can you figure out a value of x that if you multiply those 3 together, you get 96? Oh, look at that. X is 2. So, students found the right answer. X is 2. And therefore got 3 out of 5, just barely passing. Might have even been 2.5 out of 5. And so a couple of things that have changed. The exam writer said, By guessing and checking, you by no means find all of them. How do you know that that's all of them? The only way to find all of them is if you do it algebraically. And the consensus that comes up as a result of questions like this is almost all exam questions now, if you need to do it algebraically, they add the word algebraically in there to make sure that if you get the right answer, you haven't stopped and not figured it out algebraically. Unfortunately, algebraically in this one is annoying. Why is it annoying? Yes, this is factored, but factored only helps us solve something if the other side is equal to 0. So we first of all have to multiply everything out. So I'm going to multiply these ones together and get x squared plus 12x plus 20. And then I'm going to multiply the x through x cubed plus 12x squared plus 20x. Wow, what a recovery. And then I can move the 96 over. And the only way I can solve this is if I factor it. And I don't have a calculator. Now, possible factors of 96 are like 1 and 96, 2 and 48, 3 and 32. Chances are, mental math-wise, without a calculator, it's either going to be the 1 or the 2 that works. They're not going to get you to plug in 96 into x cubed and check if it equals 0. Okay? And this is where the guessing and checking that we actually did at the beginning to see that x is equal to 2 was really helpful. So we'll finish this up tomorrow.